It's something we do 100 times a day. We click, we type, and boom, things just appear on our screen. It really feels like magic, doesn't it? But it's not. It's an incredibly fast, perfectly coordinated dance happening inside that box. So in this explainer, we're going to follow one single click on its epic journey, from your finger, deep into the heart of the machine, and all the way back to your screen.
I mean, it seems so simple, right? You want to open an application, you move your mouse, you click the icon, and boof, there it is. But that single click, that one tiny action, it kicks off this insane, lightning-fast chain reaction of billions of operations inside your computer. We're going to trace that exact journey step by step.
To make sense of it all, we're going to break it down into 3 simple phases. First, you give the command. Second, the computer does its thinking. And third, you see the result. That's it. That's our roadmap for the next few minutes. Okay, so let's start at the very beginning. The whole thing kicks off with you. Whether it's a click of the mouse or a tap on the keyboard, you are the one who sends that very first signal. Now, you can't just, talk to your computer's brain directly. You need a go-between, a messenger. And that's exactly what input devices are. They're basically translators, turning your physical actions, a click, a key press, your voice, into an electrical signal that the computer can actually understand. So for our little story here, the mouse is our messenger. And that single click isn't just a click. It gets translated into a super specific digital command. Something like, hey, the user wants to run the program tied to this icon right here at these coordinates on the screen. And just like that, an electrical signal is off to the races. So that signal is now flying through circuits and wires at pretty much the speed of light. And it's headed for its first major stop, the computer's central brain. This is where the real work, the real thinking begins. All right, welcome to the CPU, the Central Processing Unit. If your computer was a massive construction site, the CPU is the foreman. It gets the big picture plans from the operating system. You can think of the OS as the site manager. And our little click has now been turned into a direct order. Launch this program. The foreman has the blueprint and is ready to get to work. Okay, so the CPU is ready to go. But here's the thing. It's just a processor. It doesn't actually store the application itself. It needs to get the program's files from somewhere. So, where does it go? This brings us to the next couple of critical pieces in our puzzle. Think about it. Our foreman, the CPU, can't really work with blueprints while they're still locked away in some big filing cabinet. No, it needs to bring those plans over to its workbench, where it has everything laid out, ready for immediate action. And that workbench, well, that's what we call RAM, or Random Access Memory. It's the super fast but totally temporary area where the computer dumps all the data it's working with right now. So when we open our app, all its important files get pulled onto this workbench, so the CPU can grab them in an instant. Okay, but wait. If RAM is just a temporary workbench, where did all those application files come from in the first place? I mean, where did they live when your computer is turned off? For that answer, we need to go to the library. This is your computer's long-term storage, which these days is probably a hard drive or, more likely, a solid-state drive. Think of it like a giant library or a massive filing cabinet. Every single thing, every app, every photo, every document you've ever saved, it all lives here, just waiting to be checked out. And this is really the key difference right here. You've got the workbench. That's RAM. It's incredibly fast, but it's also temporary. The second you turn off the power, poof, everything on it is gone. It's volatile. Then you have the library. That's your storage. It's a bit slower to access, sure, but it's the permanent archive. Your data is safe there, even with no power. It's non-volatile. For your computer to do anything, it's constantly moving information from that permanent library to the temporary workbench. So let's put this whole sequence together. You click the icon, the CPU got the command. It then shouted out, hey, I need the files for this app. Those files got copied from the library, your storage drive, and were then neatly laid out on the workbench, the RAM. And it's only now that the CPU can actually start doing its job, reading the instructions right off that super fast RAM. Okay, so deep inside the machine, the CPU is crunching numbers, running code, figuring out exactly what our application is supposed to look like. But all of this incredible work is invisible to us. It's time to close the loop and actually show us the results. You remember how we needed a messenger to talk to the computer? Well, now the computer needs a messenger to talk back to us, and these are the output devices.
Their whole job is to take the result of all that CPU magic, all those ones and zeros, and translate it back into something we can actually understand, something we can see or hear.
Right, so we're talking about things like your monitor, your speakers, maybe your printer, but for our clicks journey, the CPU sends its final visual masterpiece through the graphics card to the most important output device for this job, your monitor.
And just like that, we're at the final step. The CPU's instructions are telling every single tiny pixel on your screen exactly what color to be and how bright to be, and together they form the application window. So from your finger to the CPU, from the library to the workbench, and finally back to your eyes, the journey is complete. Now, we've just spent a few minutes walking through this process, but here's the part that'll just blow your mind. How long does this actually take? The whole trip from your click to that window popping up on screen, it happens in just a few hundred nanoseconds. We're talking billions of a second. It is an unbelievable symphony of components, all working together at a speed that's almost impossible to wrap your head around. So, the next time you click on an icon, maybe you'll have a new appreciation for that incredible high-speed journey you just kicked off. I mean, this basic process, input, processing, output, this has been the foundation of computing for more than half a century. Which, of course, leaves us with one last big question. As we barrel into an age of AI and quantum computing, what will the computer brain of tomorrow even look like? What will this journey be like in the decades to come?